Hello, class. All right, back for the second activity in Unit 9. So for this here, we're going to continue with our writing equations to represent situations. So multiplication and division, we're going to write one kind of each equation for each situation here that's presented. I'm going to show you some diagrams here for those of you that still want to use the diagrams. I'm going to show you what they look like in a little bit. So first we want to try to understand the situation. Here in number 1, Jada bought 3.5 yards of fabric for $21. How much did each yard cost? Well, hopefully some of you can remember back to previous unit. Remember when we wanted to find out how much of one something was? We would call that the unit rate or the unit cost, right? We wanted to do that. And think about how we did that. We wanted to find out how much 1 yard is. We would divide by how many of yards they're talking about here. If we're talking about 3.5 yards being a certain amount, we're going to divide by the number of yards. It's going to be dividing by 3.5. So for our division equation, we can take this and say that it's going to be the $21 divided by 3.5. 3.5. Okay, so we can think about it like that. We can also think about it in terms of you're going to be having the multiplication, the 3.5, and you're going to be multiplying that times an unknown. And that's going to give you the $21, right? So those are ways to think about it with equations. Okay, to solve the question, of course, you only need one of these equations, but we really want you all to understand how you can write both a division equation and a multiplication equation for the same situation. Okay, now you might be looking at this and you might be thinking, wait, 21 divided by 3.5, that seems like it could be really, really tricky and really, really hard to figure out. There's the long way that we can go through this explanation to work it out, and I'm gonna do that quickly here, well, as quickly as I can. But then I'm gonna show you the easier way. All right, so I want you to be able to see both one of the ways that we've been using before, which will totally work, but then an easier way to be aware of. All right, so here is the longer way first. Okay, so 21 divided by 3.5. That's 21 divided by 3 and 1/2. Okay, so remember when we do calculations, any sort of computation with mixed numbers, it's almost always going to be easier for you to go ahead and make this into an improper fraction. Okay, so 21 divided by 3.5, I'm going to call that 21 divided by, and then we've got to go around the world. We've got to do 3 times 2, that's 6, plus 1 is 7, and we've got to put that over 2. Okay, and then 21 divided by 7 over 2, we just want to make that into 21 times 2 over, 7. Okay, and then we could put 21 over 1, and you could multiply across, okay, and you're going to have 42 over 7, and you can work out what 42 over 7 is. But there's another way to think about this that you really, really should be aware of, and a diagram will help you to see it. So I'm going to switch over and show you the diagram in which we can point out a little mental math trick here. So here's the diagram. $21, 3.5 yards, exactly what they described in the problem. Look at what they did. They showed you 3.5 yards. Here's 1 yard, another 2 pieces, 2 yards, 3.5. They broke 1 yard into a half. And so let's count how many half pieces are there. 1, 2, 3, 4, 5, 6, 7. So there's 7 half pieces in 3.5 yards. 3.5 is talking about 7 halves. Okay, that's just the improper fraction version of saying 3.5. So if there are 7 halves, well, you can see up here they're mentioning how, well, we can take 21 and we can divide that by 7 pretty easily, right? 21 divided by 7 is $3. So a half yard would be $3. And so if you want to find out what the whole yard is, you just double the 3 and you get 6. Okay. The same thing would have happened here if you would have worked it out. You would have had 42 over 7, and 42 over 7 equals 6, right? It's being tricky for me today. 42 over 7. That's going to be equal to 6. Okay, I'm going to clear all that out there. All right. So again, as you guys should know by now, you can always write your work down on a whiteboard or on a pencil and paper and snap the picture and upload it. That's totally fine if you are more comfortable with that way. All right. So for number 2, 4/9 kilogram of baking soda costs $2. How much does 1 kilogram of baking soda cost? Okay, so it always is good to try to make sense of what's happening in a problem before you get down to the nitty gritty of working it out. Just understand what's happening so you can anticipate what a reasonable answer would be. So here, they're telling us what 4/9 of a kilogram would cost. And then we want to find out what 1 kilogram costs. Well, 4/9 you should see that's less than 1. So $2 is less than what the cost is going to be for 1 kilogram, right? So you should know that right away. It's going to be more than $2. You also should see that 4/9 is actually less than half. If it was 4/8, that would be half. 4/9 is less than half. So that tells you that $2 is less than half of what the cost of 1 kilogram would be. So, if $2 was half, then $4 would be what the whole thing is. But because it's less than half, it's going to be more than $4. So you should know that right there. It's going to be more than $4, probably just a little bit more than 4, but it's definitely going to be more than $4. So if you were to get an answer like 25 cents, you would know that you made a mistake and you're going to have to go back and fix that. So let's think about the equations for this, how this is going to work. So again, as was the case with our work on unit rates, if we want to know how much 1 kilogram is, then we take how many ever kilograms they give us, and we divide it by that same amount, and that'll give us 1. So in this case, 4/9 divided by 4/9, well, that's 1. So that means we've got to do the same thing with $2. We've got to divide that by 4/9. So if we write the equation here, hopefully you're seeing now where you can write the division equation maybe a little bit before the multiplication equation. So 2 divided by 4/9, that equals, our unknown. I'll put a little blank line here. You can also think about that in terms of the 4/9 being multiplied by some unknown, and that's going to equal 2. All right, so those would be what the equations look like. Okay, so we can try to make some sense of this here. I think this is maybe another case where a diagram might help you. Okay, but let's go ahead and work through the math first and see how this is going to work here with the division. So we are doing 2 divided by 4/9. Let me write that out with my little writing utensil here. 2 divided by, 4/9. Okay, 2 divided by 4/9. This should tell you, because we're dividing by a fraction, that we're really going to be taking this, we're going to be doing 2 times 9 over 4. And 2 times 9 over 4, we can put 2 over 1. And so that's going to equal 2 times 9 is 18. And 1 times 4 is 4. And so we would have an improper fraction. We can convert that back to a mixed number through simplifying. Okay, so that's one way you can work at it. And then we can also take a look at the diagram. So let me go to the diagram for number 2. Okay, you can see the equations as I scroll down. And they go ahead and give you the answer, right? Because if you take your math here, you're going to end up getting 450. So if you look at the diagram here, basically, let's go back and you see 18 over 4. 4 is going to go into 18 4 times, because 4 times 4 is 16. And then you're going to have 2 out of 4 left over, which is the same thing as a half, which is the same thing as 50 cents. Okay, because half of $1 is 50 cents. So when you look at the diagram here, what they do is they have an entire kilogram, okay, because we want to know about 1 kilogram. So here's 1 kilogram. And since we mentioned it in ninths, we went ahead and broke it down into 9 pieces, right? You count these out, you get 9 pieces. And they highlighted 4 of them, because that's what we know about. We know that 4 of them cost $2, okay? And then so you can see here that the next 4 would be another $2, right? And then the next one here would be a half, okay? So, or actually, the next one would be 1/4 of $2, which is 50 cents. So we would draw a line here, okay? And that would be another $2. So this part would be $2, and this is going to be 1 out of 4. So 1/4, and 1/4 of $2.50. So that's where the 50 cents comes in if you were using a diagram. All right, and so on to number 3 as I erase some of this stuff out of the way. Diego can fill 1 1/5 bottles with 3 liters of water. How many liters of water fill 1 bottle? Again, we want to know about 1 bottle. The information they give us talks about 1 1/5 bottles, so we're going to divide by 1 1/5, okay, just like in the old unit rate problems. So we can take our 3 liters of bottle, 3 liters of water, and divide it by 1 1/5. Okay, so that's the division equation way of thinking about that. For multiplication, you can see that it's going to be 1 1/5 times some unknown, and that's going to give us 3. Okay, so those are the equations of that. Okay, for the division, for solving it, 3 divided by 1 1/5. Okay, let me go ahead, I'm going to write it down here. So 3 divided by 1 1/5, there's 3 divided by 1 1/5. Okay, so if we're dividing it by 1 1/5, that's a mixed number. We want to change that into a fraction. So we're going to go what you might have heard of as around the world. 1 times 5 is 5, plus 1 is 6. So this is really 6 over 5. This is still 3, still dividing. Okay, but then a little alarm should go off. If we're dividing by a fraction, we're really going to multiply times the reciprocal. So this is really going to be equal to 3 times 5 over 6. Okay, which you can put 3 over 1. Okay, there is a way to cross cancel if you see 3 over 6 as a fraction here. Okay, but if not, you're going to end up with 15 over 6. Okay, so this I'm just going to put it down here. 15 over 6. So that's going to clue us into where we're going to get our answer at. We can simplify that back to a mixed number. Okay, so if you want to look at the diagram version of this here, let's take a look at that. Okay, here we go. You can see here, they show 3 liters. They just draw a certain part, 3 liters. They broke it down into 6 pieces, okay? But the idea is that you have 5 pieces here, that's the 1 bottle, okay? But then we need to have a little bit extra. We need to have an extra piece, and this piece is 1 out of the 5 that are representing a bottle. So 1 1/5 bottles, 3 liters, we knew about that. Right? Okay, and then break that down and want to see what's going to go into each one here. And so you can see it's going to end up being 15. 6 goes into 15 2 times, right? And then it's going to be another half. What's wrong piece here? So you can see 2 1/2 is the idea here. So that's how that works. So you can pause the video if you want to review this here, and then we'll go into number 4, and I'm going to erase this again. So last question of the activity: 5/4 gallons of water fill 5/6 of a bucket. Okay, so this is a little bit interesting because you really need to make sure you are paying attention to what's going on here. We have the same situation being described here, right? We're talking about filling up a certain amount of a bucket or of containers or bottles with a certain amount of stuff, right? Water, fabric, whatever the case might be, okay? But in the situation here, you can see like for here, Diego can fill 1 1/5 bottles with using 3 liters of water. Here, he's got to use he's going to use 5/4 gallons of water to fill this much of a bucket. So what's happened is they've kind of switched the order of what's being mentioned first. 3 liters of water were being used to fill this much. So it was 3 divided by 1 1/5. Here, we're talking about 5/4 being used to fill this much of a bucket. So 5/4 should be going first in your equation here. This should be 5/4 divided by 5/6. Okay, if you actually look at the situation and don't get worried about what comes first, but just understand what they're actually saying, you should be able to see that. Okay, but that's crucial because if you switched it around, you would be getting it wrong. Right, so that's important. Okay, so this division equation, the multiplication equation that also describes the same situation, would say that you would have 5/6, and you'd be multiplying it times some unknown, and that equals 5/4. Okay, don't mind the garbage man. He's just doing his job. Okay, so here are the equations that you can work with. I guess I can add in equals here. Same thing here. And same thing here. Okay, so these are the equations. Let's look at it on a with writing it out as you're more familiar to solve the problem here. 5/4 divided by 5/6. Excuse me. So if we have 5/4, and we are dividing it by 5/6. So hopefully you can see right away that dividing by a fraction means we're going to be multiplying by the reciprocal. It's going to be 5/4 times 6 over 5. Okay, and there'd be a very easy way to cross cancel here. If you can see 5 over 5 as a fraction, that's really one whole. So both of these would become 1s, and you're just going to be left with 6 over 4. Okay, if you multiplied it out sideways, you'd have 30 over 20. But then you'd have to simplify 30 over 20, and you'd have 6 over 4. Okay, and this is going to end up becoming 1 and a half, right? 1 and 2/4 or 1 and a half. Let me show you this on the diagram. All right, here's the diagram. So you can see here, let me show you one bucket, because that's what we were interested in finding out about. Here's 5/4 of a gallon. Here's 5/6 of a bucket. Okay, and so we end up with this here. And you can see that we end up with 1.5 gallons, as we've already said, right? Okay, so there is that. All right.